Hi, my name is Magnus. Today we are going to discuss about partial differential equation and the application of partial differential equation, diffusion. Along with me is going to be Rafael, Wang Chenyao, Shari Hakimi, and Mosum Robius Suni. So we hope that you enjoy through the whole presentation. So what is partial differential equation? Partial differential equation, also known as PDE, are equations that consist of a function with multiple unknown variables and their partial derivative. In other words, partial differential equation help to relate a function containing several variables to their partial derivative. This equation fall under the category of differential equation. Partial differential equations are very useful in studying various phenomena that occur in nature, such as sound, heat, and wave. In this presentation, we'll take a look at the meaning of partial differential equation and the application of partial differential equation, diffusion. So, what is the method used to solve PDE? The first one is method of separation of variable. Method of separation of variable, also known as MSU and MSV, is a well-known method to solve PDE problems. Basic idea of MSV to seek a solution in the form of u xt equals to xx tt, where xx is some function of x and tt is some function of t. Second method is D'Alembert method, a solution to a wave equation problem. So you can see the equation below it. So next I'm going to pass it to the next presenter to continue about diffusion.
Hi, my name is Wong Yao, and now I will show the solution of the diffusion equation by using the method of separation of variables. First, let me introduce you about the PDE of the diffusion equation, which is partial of u with respect to t equals to the diffusion coefficient times second derivative of u with respect to x. To solve this equation, we need the boundary condition and the initial condition for this equation. For the boundary conditions, we will assume that the long pipe is connected at both ends by a huge reservoir. Next, we will also need to assume that the die is put at the center of the pipe and the dye is diffuses from the center of the pipe to the right hand side and to the left hand side like this. Next, we will put the coordinate system into the pipe system. So at one end of the pipe will be 0 and at another end of the pipe will be L as shown as figure 3 below. Due to there is no concentration of dye when get to the end of the pipe because there is a large reservoir connected on it, so we will get the boundary conditions of u at x equals to 0 for all time will equals to 0, and also u at x equals to L for all time will also become 0. For the initial condition, as we assumed previously, all the dye is put at the center of the pipe initially, which is t equals to 0. So we can get that the equation of initial condition will be when t equals to 0, u equals to fx. To identify fx, we need to know how the dye diffuses outward to the right and to the left from the center of the pipe system, which the position of the center of the pipe system is L over 2 as we can see at figure 4 below. And eventually, the mass of the dye in the pipe will diffuse out into the reservoirs in the end. After that, we can know that at t equals to 0, the concentration of mass of dye is equals to 0 everywhere except at position L over 2. The way to model this is by using the direct delta function centered at L over 2, which also can be written as delta column x minus L over 2. Then the unit of concentration of dye is mass per unit length. So if we integrate over the length of the pipe, we will have the mass of the dye, which can be called as m0. And for note, m0 is centered at the L over 2. Finally, fx can be identified as fx equals to m0 times delta column x minus L over 2. after we obtain the boundary conditions and the initial condition, we can start to solve the diffusion equation by using the formula u, which is the function of x and t, is equal to the product of two functions, which is the function of capital X depends on variable x, and the function of capital T depends on the variable t. Then we can substitute the formula into the diffusion equation to transform it from PDE to ODE, which is x times t prime, which is the ordinary differential of the t function, equals to d times x prime prime times t, which the x prime prime is the second ordinary differential of the function x. Next, we can put all of the x dependence on one side of the equation and all of the t dependence on the other side, which the equation will become x prime prime over x equals to t prime over dt. Now, both sides of the equation is independent to each other. Due to this reason, both sides of the equation have to be a constant. The constant is called as a separable constant, and it can be called as anything we like. For this equation, I will just call it negative lambda. After that, we will get two equations by putting everything on one side. The first equation is x prime prime plus lambda x equals to 0. And the second equation is t prime plus d lambda t equals to 0. To solve this equation, we need to use those boundary conditions we find before. And since the function of t is not equal to 0, we can get that the function of x with variable 0 is equal to 0, and the function of x with variable L is equal to 0. Later, we need to consider all cases of lambda. There is three cases for lambda, which is negative, 0, and positive. But along the calculations, we can know that lambda negative and 0 has no solution. So I will just show the case which have the solution, which is case 3. Lambda is positive. So we will define the lambda as p squared. Then we substitute this into the equation 1. Then we will get x prime prime plus p squared x equals to 0. Then transform it into the characteristic equation. We will get m squared plus p squared equals to 0. Then we find the roots of the m. We will get m1, m2 equals to plus minus pi. According to the roots, we will have the function of x, which is equal to a cos px plus b sin px. Next, we substitute the function of x with variable 0, which is equal to 0. Then we will get that a equals to 0. Then we rewrite the equation. The function of x will equal to b sin px. Then we substitute another boundary condition, which is the function of x with variable L will equal to 0. Then 0 will equal to b sin pl. Since p not equal to L, but sin pl can be equal to 0, so we can substitute as sin pl equal to 0. Then we will get pn equals to n pi over L, then n is equal to 1, 2, 3, and more. Therefore, we will get the function of x equal to bn times sine n pi x over L, n equals to 1, 2, 3. We will also have an eigenvalue of lambda, which is lambda n equals to n square pi square over L square, which n equal to 1, 2, 3, and more. Since we have the solution for function x, then we can substitute the lambda equals to p squared into the equation 2. Then we will get t prime plus dp squared t equals to 0. Then transform it into the characteristic equation, which is n plus dp squared equals to 0. Then we will get the root, which is n equals to negative dp squared. According to the root, we will have the function of t, which is equals to c, which is a constant, times exponential power of negative dp squared t. Since p is equal to n pi over L, then the function of t will equals to cn times e to the power of n squared pi squared d over L squared times t, which n is equal to 1, 2, 3, and more. Then substitute the function of x and t into the formula uxt equals to the product of function of x and the function of t. Then finally, we will get that u with the variable x and t equals to en times sine n pi x over L times exponential to the power of negative n squared pi squared d over L squared t, and n is equal to 1, 2, 3. The En is come from the Bn times Cn. Using the principle of superposition, we can know that the function of u with variable x and t is equal to case 1 plus case 2 plus case 3. Then we will get the answer of the function of u with variable x and t is equal to the summation from n equals to 1 to infinity En times sine n pi x over L times exponential to the power of negative n square pi square d over L square times t, which is the equation 3. Finally, to solve the constant En, we need to use the initial condition we find before, which is the function of u when t is equal to 0 equals to fx equals to m0 times the direct delta function of x minus L over 2. Then by substituting the initial condition into equation 3, we will get m0 times direct delta function of x minus L over 2 equals to the summation from n equals to 1 to infinity En times sine n pi x over L, which is the equation 4. Then we can compare the equation 4 to the formula of Fourier series for odd function. By the comparison, we can know that fx is equal to mo times direct delta function of x minus L over 2, and the small l is equal to the capital L. Then to find En is equal to 2 over capital L, integrate from 0 to capital L, m0 times direct delta function of x minus L over 2 times n pi x over L dx. To integrate the function against the direct delta function, just picks out the x equal to the central value of direct delta function. For this, the central value is equal to L over 2. Then we just substitute the x equal to L over 2 for the integration. Then the value of En is equal to 2m0 over L times sine n pi over 2. In the end, substitute the value of En into the equation 3. Then the final answer we will get is the function of u with variable x and t equals to the summation from n equals to 1 to infinity 2m0 over L times sine n pi over 2 times sine n pi x over L times exponential to the power of negative n square pi square d over L square t. That's all for me. Now I will pass the mic for the next person.
Thank you for the previous presenter. So now I believe everyone is able to understand how this diffusion equation works. So I'm here to conclude everything. Um, for this diffusion equation, it is very useful for different scientific fields such as medical engineering and others. For example, with this diffusion equation, we can calculate the rate of diffusion of oxygen and carbon dioxide in flowing blood, and we can diagnose the healthiness of a person accurately. So I believe everyone is able to understand everything, and that's all from group 9 presentation.